GameSide.com. GameSide.com.
What's cooking, good looking? Time for a lesson on memory address mode. How do we access the operands to do the operations? Address modes are things like immediate, the value is in the operand. Direct, the operand has the address in RAM of the value, requires one more fetch from RAM. Indirect, the operand is the address in RAM of another address of the value, which requires two more fetches. How does executing a machine code instruction access a value in memory? That's what memory address modes tells us. How do we go out to RAM and get the values we need in order to do our operations? Critical to understanding how machine code works is understanding how the code accesses computer memory. A machine instruction can access RAM several different ways. Above is an updated machine code format. Keep in mind, every CPU has its own instruction sizes and formats. This is a generic 16-bit machine code instruction. Every CPU is different. Each CPU has its own instruction size and format. Using a generic example allows us to study how binary code executes without the details needed for a specific CPU. The opcode is going to be the first 4 bits. Mode will be the next 3 bits. Mode will tell us how to access memory or how to access the operand. Register will list a 3-bit code for which register in the CPU we want to access, and our operand will be 6 bits. Opcode is short for operation code. Operand is the value or address the operation will be performed on. If the opcode is add, the operand will provide the amount to add. Many ways for operands to provide a value, from directly in the instruction, or a RAM address that contains the value, or the address of an address with the value. The operand is what's used to perform the opcode. How do we access the operand? Sometimes the data is directly in the operand. Sometimes the operand contains an address out in RAM where we can fetch or retrieve the operand from. The 3 bits for the mode specifies how to access the operand. 3 zeros means immediate mode. 001 is direct mode. 010 is indirect mode. 011 is register mode. There are 4 more not shown. We don't need to see all 8 different modes. And again, this varies from CPU to CPU. Depending on the mode, the operand will be accessed much differently by the CPU. Immediate mode means the operand is a value. Direct means it's a memory address. CPUs have special purpose registers like the IR, PC, and the accumulator. They also have general purpose registers, R0, R1, R2, R7. These bits specify which general purpose registers to access. Registers are CPU memory. Accessing them is much faster than retrieving data from slower RAM. An instruction that uses a register for the value is faster. 3 bits for the register, 2 to the third power is 8. That means we can access up to 8 general purpose registers. Inside the CPU, we only have room to show 4 of the 8 general purpose registers, which are going to be 8 bits each. I wish I had more room here to show 8 registers, but we don't. We only have room to show 4, and the dots indicate we have 4 more general purpose registers. The 16-bit IR is also shown with artificial dividing lines to separate each part of the machine code instructions. Just to remind you, I put these lines in here to say this is the opcode, this is the mode, this is the register, this is the operand. This is the von Neumann instruction cycle. This example will focus on this execute step. How does an instruction get executed while it's in the IR? Here is an example of an executing machine code instruction. The 4 bits in the opcode are set to 0001. That is the load instruction. The 3 bits for the mode are set to 000. That is immediate mode. The 3 bits in the register are set to 010. That means use R2. Immediate mode says load the operand directly into the register. Transfer the bits directly from the IR to R2. See the bits in the operand? Immediate mode says I want to load those into register R2. Now, why did these bits go into R2? Because the register bit said go into R2. 0 filled, there are an extra 2 bits in the register. The register is 8 bits. The operand was 6 bits. So we 0 filled these 2 bits. And then the 010100 came directly from the operand. No additional access of RAM is needed when you use immediate mode. Immediate mode says use the bits that are in the operand. Load those bits straight to the register. Analyzing a different instruction, the 4 bits in the opcode 0001 are the load command. The mode bits 001 is set to direct. Use direct mode to access the operand. The register bits are 011. That says use R3. Direct mode says load the operand from RAM memory. View the operand in hex. If you look closely at the 6 bits in the operand, 101011, that is hex 2B. 1011 is B. Use memory address 2B. Use the value at that RAM address and load it into R3. So go to address 2B in RAM. There you see some 8 ones and zeros at 2B in RAM. Load those into register R3. Now, why did they go into register R3? Because the register bit said use R3. One additional access of RAM is needed. Direct mode says this is a RAM memory address. Figure out the RAM memory address, go to that location, and load it into our register. Analyzing another instruction, here's a new instruction loaded into the IR. The 4 bits in the opcode 0010 say this is a store instruction. The 3 bits in the mode field 001 says this is direct mode. The register bits are set to 001. Use R1 as our register. Direct mode says store the register to RAM. View the operand as a hex memory address 0x28. If you look closely at these 6 bits, it translates to 28. We want to store the value in register 1 in RAM memory address 28. The value in R1 1110000 is stored in address 28 of RAM. The operand is the address. That's what direct mode means. The operand is an address in RAM memory. One additional access of RAM is needed. Obviously, if we're going to store something from the CPU into RAM, we're going to have to access RAM memory to do it. Looking at a new instruction loaded into our IR, the opcode bits are set to 0001. That is the load instruction. The mode bits are now set to 010. The mode bits say use indirect mode. The register bits are 000. That is R0. Indirect mode says the operand is a memory address of another address which holds the data we want. This requires 2 extra accesses of RAM. Indirect mode. Start with the operand, which contains 101110, which is hex 2E. Fetch the contents of hex 2E. There's 2E right there. Fetch its contents from RAM. Its contents are 00110101. That is hex 35. If you look closely, there's a 3, there's a 5. Fetch its contents and assign it to register 0. Indirect mode says go to this address. From that address, go to this address, grab the contents of this address and move it into register 0. Now, why did it go into register 0? Because the 3 bits in the register part of the instruction register said use register 0. Did you see the 2 fetches from RAM? The first fetch was this location. The second fetch was this location into register 0. That's indirect mode. Looking at a new instruction in the instruction register, the 4 bits in the opcode 0001 indicate this is a load instruction. The 3 bits in the mode 010 say this is indirect mode. The 3 bits in the register 011 indicate we should use R3 for this operation. Indirect mode says the operand is a memory address of another address which holds the data we want. This requires 2 extra accesses of RAM. Indirect mode. Start with the operand, which contains a 110001, which is hex 31. Fetch its contents. Fetch the contents of 31 from RAM memory. When you get there, the contents there are 0011 1000. There's the contents of hex 31. This is hex 38. If you look closely, there's a 3 there and an 8 there. Go to address 38, fetch its contents, and assign the result to R3. So I fetch this memory address, which tells me to go to this memory address, grab the contents of this memory location, and load it into R3. Now, why R3? Because the 3 bits in the register part of the IR said use R3. That is indirect mode. Fetch one memory address to get another memory address, and contents of that memory address should be loaded into the CPU. Looking at a new instruction loaded into the IR, the 4 bits in the opcode are 0101. That's the opcode for the add instruction. The mode bits 011 are set to register mode. And the register we want to use is 30, so we're going to use R0. Register mode says use the CPU memory, which is faster. Do not fetch from RAM. In this case, add register R0 to the operand R3 and calculate the sum. Register mode is only using the lower 3 bits of the operand. Those are used to identify the second operand. What we're going to do here in register mode is add R0 because of these 3 bits to R3 because of these bits. Grab R0 and make that the left operand of the add instruction. Grab R3 and make that the right operand and calculate the result. Add the 2 registers together. Because we are only accessing register memory and not RAM memory, this operation can run faster. Registers are internal to the CPU. They don't have to go out on the bus to retrieve data, so they can operate much faster than commands that use RAM memory. These address modes are pretty much the same for all CPUs: immediate, direct, and indirect. Register mode is different from CPU to CPU because the number, size, and types of registers are different between CPUs. Register mode does not need to access RAM, so register mode is a much faster way to operate on data. But again, each CPU does it slightly different. Register mode, in this case, is only using the lower bits of the operand, which are used to identify the second operand. Register mode says work on my internal memory to the CPU, therefore it can do its job, like adding 2 registers together, much faster than if it required more access to RAM. RAM is much slower compared to internal CPU memory. Very important. Where does the result go after an add command? Let's add R3 to the immediate value from the operand and put the result where? Where does the result go after the add? Some CPUs have an implied register named the accumulator, and all the results are placed in the accumulator. I've loaded a new instruction in here. 0101 says this is an add command. The mode indicates we're going to do an immediate, but we're going to do it slightly differently this time. Immediate mode says we're going to take the register R3 specified by these 3 bits and add it to the immediate value in the operand. That's what I'm doing here. Here's the value in R3 because this is set to 3. Here's my immediate operand. Let's add those together. Now the question is, my result 01011000, where does that go? On many CPUs, it goes straight to the accumulator. Adds, subtracts, multiply, and divides happen in the accumulator, and when you're done with the operation, store the result back into the accumulator. RISC, or reduced instruction set computers, generally always use the accumulator as their implied register. CIS computers, complex instruction set computers, sometimes have more complex commands, like an add R1 to R2 and store the result in R3. That command, where the result of R1 plus R2 is stored in R3. It really depends on the type of CPU we're looking at, whether it goes into an applied register or a register specified by the user. Once again, we'll do an immediate add here. We'll add R3 to the value in the operand and store the result back into the same register R3. That does sometimes happen. I'm going to add register 3, whatever was in register 3, to the immediate value here. When I calculate the result, 01011000, it can go back into register R3. That happens more often with CIS computers than RISC computers, but it does happen. And you've got to be aware. These commands all operate slightly different from CPU to CPU. But once you learn the basic principles, you understand all CPUs. One of the reasons why we're not studying a specific machine code is I want you to see in general how CPUs work, not the specific operations of one particular CPU. The concepts are the same from CPU to CPU, but some slight details vary from different CPUs. In summary, address modes. Immediate address mode says the value is in the operand. These bits represent what we want to add, load, or store. Direct. The operand is the address in RAM of the value we want. This requires one more fetch from RAM. In direct mode, these bits are a memory address, and we need to go out and get that memory address. Indirect, the operand is the address in RAM of another address of the value. This requires 2 more fetches. This would be the address of another address in RAM, and that's the real value we want. Finally, register mode. Hard to be exact, it's different from CPU to CPU, especially between RISC and CISC architectures. But registers mode generally says operate on data that's already in the CPU. Do not go out to RAM and use data from RAM. Use the data that is already loaded in my CPU registers.
Ginside.com